Okay. Hello, everyone. Can you see us? Put something in comments that you see us, that you hear us. Evgenia, do you see comments? Because I can't see anything because my screen is.
Yep, I see. Everything is good.
Okay, so good afternoon to every one of you. Welcome to our second Solution Architecture Community Meetup. And today we will talk more about solution architecture mindset and about mindset of solution architect. And second part will be about API layers and why do we need them. You may ask your questions in English to speakers and to me as well as an organizer. You may put them in comments. Just one notification and warning. I'd like to notify you in advance that we don't allow hateful, racist, and political comments and spam and content that promotes services or products. So I give the floor to Dzmitry, who will tell us about solution architect mindset. So Dzmitry, it's your turn.
Yep. Hey, everyone. I hope you can hear me, right? I can see the comments as well, but still there is a hope, right? So like mind the gap, and this is what we are going to talk about. And thanks for having me first off. And this is not the new topic. I've presented this back in the days on the Z conference of EPAM, but now it's a great opportunity to share it with the even wider audience and whom this might be relevant to. It might be relevant to software engineers, but to any practitioners who consider the solution architecture as a career path, right? So I really hope that it will be useful for each and everyone who is on the call. And let's get started. Let me try to, very brief agenda. I'm going to introduce myself first off, right? And then we will discuss what the gap is, because in order to fix and to address something, you have to identify where is the gap, right? And by no means, keep in mind that we have 30 minutes only. I'm not trying to bring you the set of steps you have to follow, but rather my goal is to push and force you to think about it, because once you are aware of it, I hope that it will help you to move on and try to address those gaps, right? So definitely I'll be sharing some hints and observations. Majority of them are based on my personal experience as an architect. And then for those of you who will stay on the session till the end of it, there is a little bonus. So let's get started. Intro. I'd like to start from the self-introduction. My name is Dmitry Tabolich, and I'm Senior Solution Architect at EPAM, based in Minsk in Belarus. And I work as a solution architect, meaning I'm a practicing guy, and sometimes I do help our learning department to educate people in this field, but also I'm a community speaker as well. The topic for today, it came, as I mentioned, it came out of my experience, because at EPAM, I'm not going to talk today about like who is solution architect. There is plenty of materials over the internet you can find, and the ones where EPAM presents their vision of our internal structure, how solution architecture discipline or practice looks like, right? But still, on the overall, one of my favorite pictures on that is like we do have software engineer in common case, right? And where people grow from the junior up till the D4, like lead and even chief level, as a technologist, with some technology stack in background. Would it be .NET, Java, JavaScript? But the thing is that there is a depth of some technical knowledge, and the focus is, and such people are great in solving technical tasks, applying their primary skill and skill set and solving them. But then as people decide to move to the like solution architecture, this is what happens or supposed to happen or happens on practice. Beside the depth of the technical focus, right? There is a horizontal line which indicates that you start to gain more experience and you start to apply your knowledge in a much more areas than that. And it's not only technology anymore, because as you grew up, there is a business focus as well. So it's not you go and try to solve whatever task right away with the technology, but rather there is a like business context, right? You started to learn more what is the actual business problem you're trying to solve. Then there is a governance piece. And as the role and level of maturity and exposure grows, there is strategy piece to it. So effectively, it's sort of transformation, right? Or mutation, as you see. But when it comes to the any technical role, it's there are two types of skills. We are talking about, like, it's a hard skill, meaning it's your skill in .NET, in Java, in the design, in microservices, in any like tangible artifacts or assets, right? And there is a like what's considered as a soft skills. It's a communication, negotiation, the way you can present and speak to people, stakeholders management, all the stuff which goes to the category of the soft skills. So the question then, where the gap is, and when I start to think about this process or this same picture, but from my like solution architect perspective, and the gap is in the mindset. And the tricky part with the mindset, it's not that easy to go and read the book and now overnight you become an architect, right? And again, from my experience, I saw many times people are submitting their profiles for the promotion, and they say, hey, I would like to, as being a lead engineer, I would like to start playing the solution architect role. And even if those people are promoted successfully, it's all right to have another job title. But the gap or the problem is that in order to play the architect role, it's quite essential and important to have to start thinking as an architect, right? And this small one, but still being developer or having developer mindset, but somehow try to think or have architect mindset, it's really difficult to learn how. And as I mentioned, it's not like follow these steps and it will be success. But at least my goal is to share some of the source and my perspective to it, right? So you will be aware that the gap exists, and what are the indicators that you're still having like software engineer mindset versus architect mindset. How to address it? It's like it could be your choice. So back to the actual topic. Before we will start, and I asked this question myself, how to educate people around this and how to bring the knowledge and perspective, and how to let people, how actually solution architect thinks, right? Because mindset, it goes to this category. And I just decided as a tactic to apply, I just decided, what about I put some situations, and given the same task or the same situation, I will show how typically the solution architect thinks and how, based on my experience and observation, software engineer thinks. So it will be obvious enough to understand where the gap is. My slide pack is all about the set of little stories, how same task or same problem is approached by these two categories. Again, as a disclaimer, by no means I'm trying to say which one is better, because it's all contextual, right? And not saying that, not trying to say that software engineers, it's like my goal is to show the difference, not to show which one is better. So let's get started. Let's say there is an approach and there is a task to be done, right? The typical software engineer approach in this case, let's get it done. I mean, to put the hands and get it resolved. But from the solution architect perspective, it's quite important when you have a problem or task to solve. It's really difficult. It's really important to understand not just to solve this particular task, but what exactly this particular task is supposed to solve on the bigger scale, right? So it's not like us implementing the integration between system A and B, but rather having this integration in place, what exactly we are trying to achieve, right? So even if that it will we will end up as a solution, the integration part, still is quite important to think what exactly we are trying to solve, but not how we are going to solve it. So then the next situation, the experience sharing, right? And applying on practice. So like a typical way of thinking, if there is a task which looks like already known, the approach here is like, I know how to do it. So I've done it many times in the past in my project. I do have even a piece of code which already solves that. Let's apply and let's get it done again, right? But from the solution architect perspective, whenever the task is, and whenever you have to come up with the solution option, there should be, or like one of the definition of the solution is that if you have only one solution, you don't have solution. It's not me who said that, but it's like from the industry, meaning that trying to solve or come up with the solution, you have to always think what else could be done in order to solve it. Because sometimes the solution itself, it doesn't require technical or doesn't include technical component to it at all, right? So that's the difference. And again, I hope that you started to understand the way we are going to approach this mindset. So let's move on. Software engineer, and there is the documentation piece. I say it many times, people, not all of the people, let me put it that way, like to write the documentation. It's because documentation is not a code. So from software engineer standpoint, writing documentation is sort of extra effort or waste of time sometimes, right? But it's still like, it's a bit boring stuff. At the same time, as a solution architect, as you do this transition from the software engineer to solution architect, writing documentation becomes like your day-to-day duty, simply because that's the artifact you produce in order to collect the knowledge, in order to address and document all the decisions you make. And in order, this as an artifact could be shared with the stakeholders, right? And the importance of the documentation is quite high. And at the end of the day, like whenever you design something and it's in your head, if you cannot properly document it and share with the stakeholders, it might be greatest architecture ever, but it will be still just in your head, right? And also, like, that's important from the solution architecture standpoint. The documentation is a really good thing for the knowledge sharing, right? So let's move on. Software, it's like whenever we get something as a task, quite often in the practice, I see that being focused on solving particular problem, like let's add this button or let's implement this integration again. The software engineer being like really task focused or task oriented. Quite often the concern is how exactly the bit of functionality works. At the same time, from the solution architect standpoint, even understanding this bit is perfectly fine and important, but ideally it should be the bigger vision how this particular implemented piece of software actually affects the overall system as a whole, right? And it's sort of self-explaining, but why it's important? Simply because it's difficult and the complexity of the systems you are building today is quite high. And while still focusing on the quite modular thing, you still have to keep in mind the overall context because of security, because of performance, and how whatever we introduce into the platform, how it might affect potentially the overall system, right? So again, that's the difference. Not necessarily strict in exact this, but try to gauge whatever you make such decisions. Try to understand if you take into consideration the system as a whole, right? Because if you do, probably you act at this particular moment as a solution architect. Let's move on. That one of my favorite ones. I've spent some time working with especially JavaScript world in .NET. Is less common, but still, what I observed on the practice, like when you talk to development team, there is plenty of ideas how to solve a particular problem, bring in the framework X, and let's add this package, and we'll get this component out of the box, right? And again, why I mentioned JavaScript, because of the ecosystem, it's quite rich. A lot of small libraries you can easily plug in and combine the application. But even if it sounds quite straightforward and easy from the development standpoint, from the overall architecture standpoint, using framework X, first off, it might introduce something what is quite unique to the skill team has, meaning only one person might know it, and effectively it might affect the overall time and team has to spend on it, right? Because of learning, the effort or the budget at the end of the day. So whenever we introduce something like a new framework, there should be clear understanding how it will impact the overall the overall aspect of it in the mid and long term. And sometimes, and again, based on my experience, some of the clients, they do have quite strict procurement model, meaning that the IT compliance group, it's not simply allowed to bring whatever package which is your favorite one to just they have the grid on the screen or any like UI control. It might easily not be really compliant from the company IT standard. And this is like what solution architect has to consider. And it is less common for the software engineers, right? Still keep this in mind, and you'll identify it. So software engineer, and it's all about communication, right? And quite often, I'm sure, like at least some of you should have been seen this on practice. If you talk to technical people, and solution architects still considered by business folks, the solution architect is still techy person, meaning the technical. But that's the thing, like how to become and how to start speaking about the same thing, but in a different language. Because when you speak to the software engineers, quite often the discussion is all around the API, which is talking to database, and there is a server. And at the end of the day, the front end and the back end, all this technical terms. And the worst case I saw in practice, business people start talking in the front end and back end terms, and almost every single business person, they know that in order to implement this business functionality, they need this AWS Lambda, which is an indicator for me that they're in a close collaboration with development team, right? Because ideally, what needs to happen from the solution architect standpoint, whenever you present something to the stakeholder, it could be if your stakeholder group is a infrastructure team or technologists on the client side, then the language you use is fine to use Lambda and API and backend, right? But if you're presenting the solution to the people who has a business problem, ideally the solution should, or you should speak or like business language. Which components are we going to have, how it will be addressed, not on the backend versus frontend or API, but rather how overall the problem is supposed to be solved, right? And from the tactics standpoint, you can use the view and viewpoint for that and have nicely outlined components diagram, which might not have technology at all. And that's the indicator. So just keep this in mind whenever you speak and communicate the decisions that the design you have, right, or the way you're going to solve the problem. The language defines the way you're thinking about it. Hope it makes sense. Let's move on, and it's all about the problem solving skill, I would say, or its classification of the problem. And the Stack Overflow here, I don't know if it's still popular, but it's definitely one of the well-known approach in the industry. Let's go to the Stack Overflow. Probably there is a piece of code which might be adopted for our problem as well. And here we go, right? At the same time, from the solution architecture standpoint, I'm not saying that, and again, based on my experience, almost all the problems in the industry already solved. Definitely there are some cutting edge stuff, there are new areas, but at the end of the day, you can classify, or the key skill here is to classify the problem first. Because if you're able to classify and say, hey, it seems that what we are going to build, it looks like it's a data platform problem, or it's a big data, right? When you are able to identify which area the problem belongs to, it's way more easier for you to find out the proper solution. And the reason for that, again, as I mentioned, from the solution architecture standpoint, there is still a huge level of reuse. There are plenty of blueprints and reference architectures, but the role of the architect is to classify it properly. So if you are dealing with e-commerce problem, there is huge amount of e-commerce platform. You don't have to build the new one in .NET from scratch. You can definitely take a look at what's available, and if something on the market which might help you to solve your problem, right? That's another one. It's one of my favorite ones as well. This is how how it works when it comes to the translation of the functional requirements or business requirements. Quite often I see that developers, they're waiting for user stories to be created, right? And the user story should be well designed and well defined. There is a description and there is a acceptance criteria. You just take it and you go as if you're an expert and you just implement it. It's almost code is there, right? So it's for you just to translate it to the .NET, or just to take the requirement, translate it to the language of choice, and it's all right. But when it comes to the functional aspect of it, again, it's critical to understand not just how the system works from the technical standpoint, but in which business domain are you trying to solve it, right? Because if you solve something for the travel company, understanding that the specifics of the travel domain, even for the software engineer, is quite important. And for the solution architect, it's even more important. And when it comes to retail, for instance, right? When solution architect tries to think about it, there are definitely some building blocks which already part of the pretty much all the reference architectures. So if it's a retail platform, high probably there will be order management component of it, right? There will be high probably the CRM piece and shipment module, supply chain. All those modules you can. This is first thing you start to look for if you understand the specifics of the domain itself. And this is the difference. It's not like you are completely relying on someone who will describe it for you in the user story. So you'll just read and understand. But it's essential for you to gain this knowledge and to leverage this knowledge and try to help and work definitely with business analyst or product owner and bring this knowledge and empower the team to build the requirements with that in mind, right? So that's the difference, not like requirement-based knowledge versus industry or platform or vertical-based knowledge. And that's about the career path. Quite interesting one, and I saw it in practice again many times. Like some people being a software engineer by job title, because like at least we distinguish between the job title and job function. I mean, the role you can play on the project, for instance, right? And quite often that people who are senior enough, they are considered as a solution architects, even if they hold the title right now, the software engineer. And it's not about the title itself, right? Again, it's all about the mindset and the way how to approach the the problem solving. And here, like, I already played the architect role in my project, so it's just a promotion for me. But as I shared from the very beginning, it's really difficult to turn the mind, to make it a mind shift from the software engineer to solution architect. And it's not about title. It's not like if you passed an assessment today or been promoted today, overnight you will become the solution architect, right? It unfortunately, it doesn't happen that way on practice. That's why, like, in order to start thinking as an architect and just identifying yourself as an architect, you have to understand that now you're not just technical leader of the team, but you fulfill all other areas as well, right? And the title, it's a second. It's all about, I started with that. It's all about depth versus breadth. Being and growing as a technologist, as a software engineer, you keep growing as an expert within your area quite often, right? If you're .NET, like myself, that's why .NET is everywhere here. And it's technology agnostic now, so I can speak .NET or any other language. But as a software engineer, you keep growing your vertical, your technology depth, and it's fine, because this is what makes it the difference between, like, for instance, senior and lead engineer, right? At the same time, when you're a solution architect, the overall vision of the industry should go beyond that. So you start blending and following the trends of the industry, the best practices, the clouds, whatever is relevant today or might be relevant, and try to observe where industry is going, because when you try to solve the next business problem, you should be well aware of it, right? It becomes critical. And I think that I have a couple of more. I know that we are limited in time, but still we are good. Guys, my guys, just let me know when it's time to switch to the questions. But I do believe a couple of other comparisons, and we are done. So software engineer, and it's like a strong belief in something new, right? And also, especially with the cloud technology, I saw it also many times, like, people try to adopt the trends right away, solving any problem with that. And serverless Lambda, good example of it. So everyone goes serverless, not touching microservices. It's a bit of buzzword, but just serverless is enough for this example. So, like, and people start to adopt and implement the Lambda, AWS Lambda functions everywhere, and to try to implement, it's easy. It's just deployed on AWS and runs somewhere until you're not running into the problem, right? And then when there is a problem, people start to think about and try to troubleshoot it, identify that probably we are reaching the limits Lambda has. But it becomes as a part of the troubleshooting, not upfront thinking. That's why whenever you make the technology choice as an architect to the same problem, but you consider the limitations you have and constraints you have upfront, ideally, right? So before even implementing something using Lambda, it's never worth to go and see the limits. If you will see that there is a 15 minutes and this amount of memory which could be allocated, try to guess if this is something what's okay with the problems you're trying to solve, because if not, that's probably not the best solution for you, right? And this is the difference. I mean, Lambda could or could not be applicable in a particular case, but it's a matter to get it implemented and then troubleshoot it until you make yourself convenient that it was not a really great idea, right? Or you try to, when you pick it, before you do that, you try to consider performance, latency, limitations, what might be a problem for you when you get it deployed. That one, again, it came out of one of the engagements I had. And when the developer team, they just decided that the MongoDB is the best choice. Again, nothing wrong with MongoDB, it's perfect one, right? But when the choice is made like this one, it's not about leveraging a particular technology because it's trendy, it's high, probably like everyone uses it, it's good, but you have to understand the specifics of the data, right? And the tool comes next. First, you try to, as an architect, you try to validate if it's good in your particular case, not because it just has this set of capabilities. Like it supports transactions, let's use it. Even if you don't need them for now, probably you'll need them for future, right? But here the approach is slightly different from the architecture standpoint. You analyze the data, you analyze whatever you need at the moment, and only after that you just you can consider that NoSQL is your choice. And in NoSQL field, you might have multiple choices, and you might end up with Mongo, but it should work not like you take Mongo and then try to implement any scenario you have, right? Again, disclaimer: nothing wrong with Mongo. Great database engine. One of them my favorite ones. Again, half of them are my favorite ones. The rest are just observations, right? The visibility works on QA environment. I don't know how it works in production. I know it's like contextual, not always true, but quite often people do the software which works well on their machine, like it works on my machine, right? And not me who said that, it's just an industry. But sometimes it just passed QA, like quality assurance, and we're good, we are done, right? Because no bugs identified. But from the system standpoint, it's all about ops. I mean, any system we build, the critical part of its life cycle, it's operation. So effectively we built for operation. And DevOps today became the name of the role of the person in the team who's supposed to be responsible for the ops part, right? So if there is a problem with the infrastructure, we have the DevOps guy who is responsible for that. But effectively, the DevOps in its roots, it's a culture, which effectively, if I'll summarize it, it says whatever you build, you have to keep ops part of it in mind as well, right? So if you do some tricks and you do something which works perfectly fine on your dev machine, just keep it in mind that, or when you are not putting the log items or logging into your exception handling, just think about the ops guys who will be running this in production, fighting with the bugs with no information in the logs, right? That's what DevOps means in common case. Again, I'm oversimplified it, but the main message here is that the difference is, while focusing on the dev part and passing QA as a end result, just keep this in mind that ops part will come, right? And this is where the system start to be live. A couple of more, I promise, and because I think that those are the new ones. So I partially touched this, so very briefly. It's good to have great requirements, so you just translate them to your language of choice, but it's not always the case. And that's why understanding how those functional requirements contribute to the overall business needs or business requirements is crucial for any architect, right? Same thing, but it's not just as a user I would like to, but rather as a like how to classify and what exactly this user story contributes to from the overall capability standpoint. And it's not about what, but it's all about like how it's supposed to work or how it's supposed to solve the problem. And I think that that what I see on the practice also quite often, whenever the team is working on something and there is a solution architect as a role, quite often I see, let's go to the solution architect and get an answer from him or her, and we'll implement, right? But like based on my experience, and first of the difference is that when you are architect, there is no one who you can approach with that. I mean, there might be another pure solution architect or enterprise architect still, but it's you who is supposed to make a decision. Because solution architecture role, like from my perspective, it's all about the decisions you make and also the responsibility you take, right? Because making decision is not enough. You have to be responsible for those decisions. And here, like the way I work with the developer teams, I like on my engagements, usually I try to empower the team so they can do their design decision as much as possible. But of course, I would prefer to stay involved into those because I like to have at least some governance on what's going on. Otherwise, we'll be seeing the situations like these frameworks, and there will be zoo, and it will be really difficult to maintain what we have built. And bonus, the short one for those of you, because I cannot see anyone on the list. I was hoping that it's another format. I'll be able to speak to people, but still talking pretty much to myself because I cannot see who is in the chat. It's not me, and that's the bonus. I mean, I highly recommend this book. You can go and find it over the internet, but it's really good one to read because the observations and the gaps I identified and shared with you today, it's not just me who identified those. And why I like this particular one, because if you will find the stories like these ones, it's not about the cloud or microservices. It's all about the situations and stories from the real life where you can learn more how the software architect is supposed to solve or supposed to deal with a particular problem. So I'll stop here and thanks everyone who is still following and passing it over to you guys.
Thank you. It was great. So we have several questions in our chat. Let me ask a couple of them. A question from SHD. Guy, I don't know who is it. I think every software engineer should be a little bit solution architect in order to make lean, agile projects successful. Dzmitry, what do you think?
I absolutely agree with that. It depends, like to some extent, I would say, right? Because if you will start to play the solution as a software engineer, if you'll start to play a lot of solution architect role, you might fail the expectations of the stakeholders, right? But yes, I would agree. That was what was my talk about.
Okay, so next one. So the solution architect mindset should be industry specific, and therefore the translation to another industry might be a problem for an architect. Is it true?
I would not say so. It's not like industry specific. If the industry here is like a vertical, meaning the travel versus healthcare, right? It's just one part of the knowledge, right? It's a business domain knowledge, and I do have a few of them, for instance. But the majority, as you saw on my deck, the mindset itself, what the difference in thinking, they are technology agnostic and they're industry agnostic, right? So that's why I would not say so that it's an industry specific. It's more how you solve same problem, which tactic do you apply.
Okay, cool. So Sergey Krupina asks, what about control of developers? Should SA control devs where they develop the suggested architecture right way?
Yeah, that's great. It was like the last one or the one before this. People don't like when there is a control on them, right? That's why there is a nice word for that, which is called governance, which effectively it's not equal to control, but yes, like there should be governance on any architecture. Otherwise, and I saw it on practice, you have an architecture vision, which is then translated to design. And if you don't have proper governance in place, it's difficult to predict what the team will end up with, right? That's why having architect involved into the process as a governance piece, that's absolutely must.
Okay, thank you. So all this deck is more about agile lean mindset, in my opinion. Do you agree?
It's related, right? So I mean, following those principles, you might increase the lean score of your engagement, but agile lean is slightly different thing. I mean, there might be another talk about this. I'm a huge fan of it as well. but it's not lean and agile. I would not agree.
Okay, and I see last one from Anjali Singh. You mentioned breadth versus depth for a solution architect. Should an SA have depth in one or two business technology domains and breadth on the rest?
Yeah, like effectively, you remember the picture, right? Eventually, as you grow as an architect, the engagement type is changed for you. That's why the number of the business domains, the depth of the business domains and the number of those, eventually it will grow as well. So I would say it's true, especially with the level, because applying to myself from the business domain standpoint, I do have comprehensive experience in travel, in retail, and healthcare, and customer engagement space. So those are my domain expertise, right? At the same time, some technical, like I'm AWS guy, so like I do practice technology and I have quite deep knowledge of this as a technology. But overall, I think that this is what this very first picture was about: how the depth of the software engineer becomes this slightly strange figure at the end of it, right? Because when you have those extra knowledge bits applied to your profile. So yeah, I think that it makes sense.
Thank you. Another one question from Ivan Kislov. In order to become a programmer, I need to write Hello World application in random language. Where do I start to learn how to be SA in practice? What is Hello World for SA?
Just start from thinking as a solution architect, right? I'm sure you can try to think about the problem you're trying to solve even now, and try to think how to approach it holistically from the solution standpoint, right? Not as a programmer, not as an engineer, but how would you approach it as if it's just a business or the problem which has another solution, right? And again, instead of just practical example, very brief one, I saw it many times on the technical interviews with people. You ask people to build something which looks like the CMS, the content management system, right? Like we have to put some pages, then it gets to be rendered as a website. Majority of people who come from the software engineering, they will start, and if they are .NET based, they will start putting the .NET web application, ASP.NET MVC or something else. At the same time, the solution here might be the Drupal or any headless or any traditional CMS system, right? Because the problem itself, it's already solved. And this is the difference. It's not necessary to build your own CMS from the very beginning. So just that's a great question. I like it. And I would suggest to start from identifying the ways how solution architect thinks, not from the microservices and cloud. I encourage you to do so.
Okay, thank you. I see that there are no any other questions. So thank you very much. Many people also say thank you to you in the chat. So it was a great presentation.
Thanks, guys. And thanks for having me.
Thank you. So, but we continue with our another speaker. This is Abhishek. Sorry if I pronounce incorrectly, but you may introduce yourself. Let's talk about API layers. Sorry, it seems you are muted. Could you unmute yourself? Now you are muted again.
So can you see my screen?
Now it's okay. Now it's okay, and we can see your screen.
Yeah, thank you very much. Thanks all for joining the presentation. Layers APIs have them. So the title of presentation is inspired by some image I saw on internet with title like layers, we all have them. And my personal experience is behind this presentation. The agenda of presentation is we talk a bit about APIs and layers, some architectural styles which have been dominant in last few decades, and design patterns which impact the layers of API. I work with EPAM as solution architect. My name is Abhishek, and in this presentation, I will take a use case of a hypothetical bank that adopted APIs and then went through several changes in terms of defining the layers of API. So any organization, whether big or small, when it initially starts working with API, they start with level 1 maturity of APIs, in which there are few APIs exposed through a perimeter, commonly known as gateway. And there are some front-end applications like mobile and online, which consume the APIs through the gateway. Gateway provides some perimeter services like request response transformation, logging, and few more services. Initially, it's north-south traffic, but over time, some APIs start invoking other APIs, and the traffic is east-west also. The problem, initially, a small team can manage all the APIs, but the problem with APIs is that APIs proliferate, their numbers keep on growing, and slowly one team can't manage all the APIs. And also over time, new parameters appears, like a different one for external clients, and like in this organization in which I took as an example, when a number of APIs grow very large, or in any organization, we need some mechanism to manage the APIs. And indeed, we can think that, can we categorize the APIs into different layers, or something like we can say that, okay, this is one example of how I have categorized the APIs, that I can assume that there are some APIs which are data access APIs, which perform the data CRUD operations, basically like create, read, update, and delete operations. There are some business functions APIs which expose a business functionality, and there are some APIs which can be called as presentation APIs, which are very close to end user. They are either consumed by user interfaces, or they are directly consumed by the end users. And these APIs can be monetized also. The benefit of defining the layers is that when I write a new API, I know that, okay, where it belongs based on its purpose. I can also have a different security requirements and different security mechanisms for the different layers of API, because the APIs which are in the presentation layer, they require a more security probably, and the APIs which are in the data access layers, not directly exposed to the end users or user interfaces, they might have different security mechanisms. I can also deploy these layers in independent clusters, manage them separately so that my operations work is better. I can monitor the layers independently. And the teams can be divided, different development teams working on different layers of API. The NFRs, like availability, reliability, and especially the performance, can be defined separately for different layers of API. So for example, data access APIs can have like a performance SLA of 50 milliseconds, whereas presentation APIs might have like 200 milliseconds. It depends, but different SLAs can be defined for the APIs depending on the layer they belong. And not only that, the tech stack can be different for the different layers of API. For example, the business function APIs might be written in Java, but the presentation APIs might be written in Node.js, especially if the presentation APIs are like they are like serverless and they need start very quickly. Their interfaces also can be different. For example, the data access and business function APIs can be REST interfaces, whereas the presentation APIs can have a GraphQL interface. But APIs don't just exist on its own. They are an interface over an application, and applications are built using some architecture. So in last few decades, primarily there are few architectures like monolith service-oriented architecture and microservices, which have dominated the software architecture, software development. So like if we take an example of a bank which exists for a long time, initially it had a monolith architecture, then it moved to service-oriented architecture, then lastly it moved to microservices architecture. In monolith architecture, we have a big application that has that implements that's a lot of code. It is very well organized into layers, and there's big application communicates with its big database. So let's assume that initially we have this organization which has multiple monoliths. So for example, we have a bank which has a few monolith applications, one monolith application for managing the retail customers, another one for credit cards, and another one for wealth customers, and another monolith application for corporate customers. Now, what organizations used to do, like 10 years back, till 10 years back, they divide their organization structure was also very much influenced by this tiered approach of monolith application. So at a high level, monolith applications have 3-tier: presentation, business logic, and database tier. So organization also had a tier teams. So one team maintaining the presentation tier, another team maintaining the logic tier, and another team maintaining the database tier. And as these tiers start to grow, the tier was further divided into business functions. So within the presentation tier, a small group maintaining the retail customer online interface. The problem with this monoliths there were many problems, but from integration perspective, the problem was that these were complicated big systems, and integration technology was Corba. Like I worked in an organization where there was one system built in C, another one in COBOL, and another one in Java. And we used Corba to integrate these systems, and it was very complicated. There was a lot of manual things also, cross-team collaboration, and they were like siloed systems. So about this hypothetical bank now is tried to solve this problem, and the solution which was very popular was service-oriented architecture. In service-oriented architecture, we build a common service layer which is consumed by all the applications. So like, for example, there are multiple front-end applications, and these front-end application in itself can be monolith J2E or .NET applications, and they interact with one common service layer, and service layer interacts with multiple downstream systems. And these downstream systems were like databases, mainframe systems, legacy systems. The SOA layer was providing a standardized interface with a standard request response format in like mostly XML. And interface was also very well defined using the descriptor languages. And these services were reusable services. It was not just about web service like a SOAP XML web service, but also there were message queues and enterprise service bus. And SOA layer was handling all the complexity of the downstream systems, because downstream systems were exposing the interfaces which were complicated. They had these complicated data models, which was not easy to understand. There were a lot of different formats used. For example, I worked in a SOA layer of a telecom company, and there was Apple, which was using EDI format. SAP was using CSV format, and there was a Siemens product using Corba. And SOA layer was handling all these different formats and exposing one common formats in XML. And all the applications consuming the SOA layer had to only deal with an XML format. But problem I saw is that this SOA layer with time grew very big, and the interfaces started getting complicated. The SOA layer in itself was built using proprietary products, such as from IBM and Oracle. The learning curve was big for SOA layer, but one cannot just simply say that, okay, I want to build a SOA service, go and start working using SOA products. There was a big learning curve. And there was another major reason at the same time that like our this hypothetical bank, it has online applications, but now this banks start to think about mobile application. And mobile applications, very soon, the popularity of mobile applications started growing very fast, 10, 12 years back. Mobile applications, they needed a simpler interface. They needed access to data in more simpler formats. And there was an alternative. And that point, actually, I knew that, okay, alternative was APIs. So we had this architecture where we have a front-end applications connecting to SOA, and SOA connecting to multiple downstream systems. And now mobile application came in. Mobile application wants API because APIs were using standard HTTP verbs or methods. They were easy to learn, easy to build, with no cost. They were free from WS standards. So SOA had a lot of WS star standards, but APIs, they didn't carry that heavyweight. And while most of the SOA programs were running out of momentum because of huge cost investment in SOA layer, especially in big enterprises, the APIs came with a value proposition of generating revenue, because APIs were a sellable product. So you can build an API, you can sell it, whereas the value proposition for the SOA layer was cost saving. And now this organization was started building mobile application, and they were looking that, okay, along with that, they wanted to build an API layer. There were multiple options that we can build an API layer over the top of SOA layer, or we can replace the SOA layer with the API layer. But if we simply replace the SOA layer with the API layer, then all the complexity which SOA is currently handling, this had to be copied into the APIs, dealing with multiple downstream formats, doing a lot of orchestration among different systems. But one thing was that really good about service-oriented architecture was that we can build some services which can be reused. So I mean that we can build a service that not only fulfills the current requirement, but it can be reused in future for future business use cases. So what approach was taken was that a transformation, an IT transformation approach was taken, that, okay, a new operational data store was built, and all the data from the legacy systems, including databases or DB2, Oracle, mainframe, and these systems was copied into a operational data store, and a layer of API was built over the operational data store. And this API layer was consumed by the front-end application. So initially, it was only read-only traffic through the API layer, and read-write all happening through the SOA layer. But later it changed, but initially it was this. So this is how APIs came into picture into this our banking architecture. But then initially the number of APIs were less, and slowly the number of APIs started to grow, and now we need to do read-write also through API. And the organization was looking for some kind of a API management. They wanted to kind of a layered API approach in which they can define their security and other multiple operational things according to API layer. So One design pattern which influenced this was the API-led connectivity. And I read this on the blog of MuleSoft that, okay, we can have 3 type of APIs or 3 layers of APIs. So this I read 5 years back when many organizations were migrating towards API, and there many organizations were going to IT transformation. And this approach suggests that we can have system APIs which are close to system of records, and these system APIs are managed by the central IT team. Then we write some process APIs which are composition of system APIs, and they can do orchestration and choreography, and they are built according to the business requirement or the feature on which we are working, and they expose a business functionality. Then there are some experience APIs which are adapted to the user interface. So these experience APIs, they handle the request response formatting according to the UI requirements, and they can do more things. But this is how we can categorize. And in the next slide, I give an example of these 3 layers. So we have this data store in which we copied the data from multiple legacy systems, and then wrote the lot of system APIs over this data store. Like so, we have the data store, and this not just one big data store. Instead, there were multiple data stores. This is just a simplified version of that design. That the multiple system APIs were written, like customer API, accounts API, and transactions API. Now, these system APIs manage their respective aggregates. They expose the CRUD operations. Then there are some process APIs which do the orchestration over the system APIs and expose a business functionality. For example, get customer accounts API brings all the accounts of a customer. Get transaction summary API brings all the transactions from all the accounts of a customer and a summary of this transaction, not all the transactions. And there's an experience API, which is homepage experience API. And this homepage experience API was built because there was a mobile banking application, and the homepage of mobile banking application needed all the data in one API call. And what data it needed some customer information summary, some account summary, and some transaction summary. So like, for example, how much a customer is spending on restaurants using all his or her accounts. So this was kind of a layered approach. So this was working fine, but then there was a drawback of this layered approach that slowly all the new feature development started taking this 3-layered approach. And there was a lot of extra work. There was latency, and the service. We also used service mesh, and which increased further latency, and there's a lot of question that whether we really need process API, system API, experience API in every use case. Obviously, we don't need it, but then sometimes some design patterns get exploited and they are overused. So what was missing here was that, and if I have to start from scratch again, what I will do is that, okay, I will start with a domain-driven design. So I can analyze the domain, and then based on this analysis, I can decide that, okay, what all applications I need, and what all, and maybe microservices. So for example, I need 4 microservices, and these all microservices will expose APIs, and somehow they will be consumed by the user interface. So at a high level, we can say that, okay, in an enterprise, at the top layer, we have channels, and at the bottom, we have data stores. And in between, I actually, we have this domain-driven design that, okay, we do some domain analysis and we can create multiple bounded contexts or subdomains. And each bounded context manages its own aggregate and the related entities. So we can put a customer and its related entities like address, contact, and KYC into one bounded context. Similarly, transactions, payments, and transfers into one bounded context. And we implement these bounded contexts independently. And then each of these bounded contexts exposes the API. So what can be that? Okay, so in this way, we can have multiple domain services, like a customer domain service, and customer domain service handles many things related to customer. Similarly, transactions domain service and products domain service. So this is how actually service layer we can build. But when the user experience is designed for the front end channel, like for example, for a mobile application or any kind of application, they probably are unaware of what kind of domain analysis or what kind of domain services exist. So their main focus is on the user journey. So for example, we define a user journey in which we are saying that customer comes to the home page of the application, and then customer goes to the product section. Customer selects a product, and there is some eligibility check done on the product, and then an offer is presented. For example, customer goes to the home page of mobile banking system, and then customer sees that, okay, they go to the products, and their customer can see some products like credit cards, loans. Customer selects a product, and there is some eligibility check done on the customer, whether this customer is eligible for the product or not. And then based on that, a final offer is presented. Or in similar, this kind of journey can be an e-commerce also, that customer comes to the home page, customer goes to products and wants to purchase the product. So this user interface layer, a recommendation is that should not directly integrate with these downstream domain services, and user interface layer should not handle the orchestration of multiple domain services, because the data it needs will not come probably from one domain service. So we introduce a layer which is similar to our experience API layer. And we say that, okay, there is an API for the homepage. There is an experience API which brings all the products which customer can apply. And there is an experience API which does the customer's eligibility check for the product which he or she has selected. And there is an experience API which brings the final offer. Now, these experience APIs can communicate with multiple domain services. They might be doing some kind of choreography, but they handle all these things. But these experience APIs are purposely built according to the user interface requirements. And I was working in a project in which the team initially built just one experience API, which was interacting with all the downstream domain services. And then they thought that this is wrong. So they built multiple experience APIs, one experience API per one domain service. So every domain service had an experience API. And then they thought, okay, this is also not right. What I believe is correct way is that, okay, build the experience API exactly matching with the user interface requirements. And some places this experience API is also called edge services. The terms will differ. And so if we take this concept, what do we discuss till now? That, okay, we at the top we have a channel or UI, and then we have a layer of experience APIs, and or call it presentation APIs, or we can also call it edge services. There can be other names also. This layer also deals with a distributed cache, because they might be dealing with customer session. They also deal with customer authentication. And these layer interacts with the domain APIs, and domain APIs encapsulate the core business domains, and there can still be some system APIs which are for communicating with the legacy interfaces or the black box systems or some external systems. So, for example, like if you are handling payments and frauds, then there are some systems which are not bespoke developed. They are like COT solutions and been built an API layer to integrate with those systems. And sometimes their request response format is also not JSON. Something can be something else. So till now, till now we assume that okay, there is just one channel. What if there are more than one channel? There is a mobile application also, and there is a desktop application also. So there is this design pattern backend for front end design pattern, and what is says that okay, we should have a separate backend for each front end. So mobile application had its own backend, and desktop application had its own backend. There can be a common perimeter service layer which does the request logging and something more, but the backend is according to the channel. And actually, like like if we take an example of again a bank, then most recently many new features are developed only for mobile. And many organizations, they avoid building feature for the online applications because there are very few customers who are only using the online banking systems. And even if the same feature it appears in mobile, then it appears slightly different and compared to when it appears on the desktop application. This is applicable to not only bank but many other domains also. So mobile application might need some less data or some other data, whereas desktop application might be needing some other kind of data. Also, the authentication will be separate for mobile and desktop. Session will be separate for mobile and desktop. So there will be things which will be different, and that's why it's recommended to have a separate backend for mobile and separate one for the online, and a separate one for any kind of new channel that comes in. So if we take this, we can say that, okay, we have a mobile application and we have an online application. There is a common perimeter, and we have separate experience APIs for mobile and separate experience APIs for the online application. But they can interact with the common downstream domain APIs. There can still be some system APIs, and but experience APIs are different. What might feel that okay, this is okay, but at many times there will be a common code between the two experience APIs, one for mobile and one for online. And a lot of times it might feel that okay, there can be just it's just code duplication. Not always, but sometimes there is a code duplication between experience APIs, two experience APIs, one for mobile and one for online. So I found this design pattern, and I don't know exactly its latest or how old it is, but it was from eBay, and there was a concept of experience service, wherein there is a common experience service which interacts with multiple downstream domain services, but this experience service brings the data which can be reused by all channels. And the channels, they handle the presentation, but they all interact with the common experience service. So if we include the experience service in our design, we can say that okay, there will still be some experience APIs which will be built specific to a channel, but we can also on a requirement basis, on use case to use case basis, we can build some experience services sometimes which can be consumed by both mobile and online. Now this totally depends on the feature we are building, totally depends on the requirement or use case or scenario, that whether we need to build a separate experience APIs for mobile and online, or we can build a common experience service which can be reused by both of them. And obviously, actually, if we're building a common experience service, then we need to take care of things like that, okay, it should be very agnostic, that okay, it can be consumed by any channel. So Yeah. So if we now, what I think that, okay, there is some still a question can come that, okay, what is this perimeter, and what experience APIs are doing because experience APIs, they don't have business logic. So, and many times which they are doing the work like message transformation and some kind of they deal with distributed cache, but many of the work done in experience API, can it be taken to the perimeter, or it can be taken out from the, we don't need to write code for that, we can take it out from the experience API, and the work done by the perimeter also can be taken, and we can use a ready-made tool such as commonly API gateway and put it there. So so we need to write less experience APIs. Only like write experience API when we need to write some extra logic. So for example, many API gateways, they can do everything. They can handle authentication, authorization, request logging, request response formatting, everything, but probably they cannot do n+1, in which they need to call multiple downstream services, combine the results, or they need to do some apply some use case basis validated business logic. So only in those cases we write the experience API. Otherwise, we handle everything using an API gateway. So if we replace the perimeter with the API gateway, till now we didn't talk about what exactly this perimeter is, but if we say that, okay, it's an API gateway, then the question is whether we should have one API gateway for the mobile app and online app, or we should have separate API gateways. So I think that, okay, we can have, in the case of API gateways also, we can follow this backend for front-end pattern and create separate API gateways for each channel. So we can say that, okay, mobile has its own API gateway, online app has its own API gateway. And these API gateways communicate with downstream experience APIs and experience services, which interact with downstream domain APIs, system APIs. So in this diagram, there are like 3 layers. One layer is our gateway layer, and there is this experience layer, which includes some experience API, experience services. And then we have a domain APIs layer. There can be more layers, but I think actually probably sometime I can have a next presentation to continue from here. But at this point, I can say that, okay, these are few layers which can exist. And the terms I have used, like experience API, experience services, they can differ, and different organization can use different terms, but the purpose would be similar. But I definitely recommend that, okay, we should have layers, and which will help in having a good API strategy. Yeah, thank you.
Thank you very much. You may ask your questions in comments. Let me check. So for now, we don't have any questions, but I have one. So when we introduce additional layers to API, we definitely impact performance. What do we need to do with it? Do we need to close our eyes and forget about it, or is there some ways to not degrade performance? So what to do in this case?
Yeah, so this was the reason why we moved away from 3 layers of API recommended from API-led connectivity, experience API, process API, and system APIs to this, wherein we are saying that, okay, our experience API can directly communicate with domain APIs, or experience API can directly communicate with system APIs, or our experience API does not need to communicate with any downstream layer. It can handle it itself. So only if there is a requirement that, okay, we need experience API cannot do things on its own, and it needs to connect with any downstream API, then only it connects with that downstream API. I think actually if there is just one layer, in most cases, it will be just like 2 layers only. Only in some rare cases, it can have more than 2 layers. And then which can introduce some latency, because like in which project I was using 3 layers, I observed that okay, there was an extra 5 to 10 millisecond latency added with every hop. So, and this will be two-way. So we try to avoid these hops by reducing the number of layers, but there are some other measures also we took to improve the performance. We only introduce hops when it's very, very required. So I can provide more details on that okay, how we reduce the latency, but this presentation was only about APIs. So we started using event-driven, we started using asynchronous things. And initially we used service mesh, but then we found that sometimes it was not required. So yeah.
Yeah, it's okay. It's okay. You answered my question. So the most important thing that it's optional to use all the layers. So you may skip some of them. Yeah. Okay. So okay, let me check another comments. I don't see any questions. So yeah, so thank you very much. It was great topic. It was interesting for me, and I think for other guys. This translation. Oh, I see that somebody says thanks. I'm wondering if and how we can implement the layered API approach with microservices.
Yeah. So this. Yes. Can I share my screen again?
Sure.
Yes, just share. Okay, so this one. Yeah, so what I am suggesting is that when we start with a new project or any greenfield, like even for existing one, we can say that, okay, we have channels, we have data stores, and in between we have these bounded context. Now, each bounded context can be a microservice or it can be a monolith application, but assume that these are all microservices. So there is a customer microservice, there is a fraud microservice, products, documents, and transactions, accounts, microservice. These are all independent microservice. So, and each of these microservice is like a domain service, and this domain service exposes API. So this is our one layer, that domain services, which later I referred as domain APIs, is a layer is a layer of microservices exposing APIs. And these microservices are built using the domain-driven design. But then the UI, the UX, what my experience is that when we design the user interface, we don't care about the domains. We design user journeys, and these user journeys cut across multiple domains. And this is where the need for experience APIs come in, that, okay, they are built according to the user experience, and they can handle cross domain interactions. See, they are like actually in domain-driven design, tactical domain-driven design, we can call them as application services, which cut across domains.
Okay, thank you. And another one question: how can we manage this API layer in Azure API management tool?
I made this presentation to be very technology agnostic. But I think that it's I don't have experience on Azure. But for example, I can say that, okay, in one of the project we were using AWS, and our all experience API layer was built using AWS Lambdas and Node.js. And it was totally serverless, whereas our domain services were built using Java. So Java is Spring Boot. So they were deployed on ECS, so which is like a container service. So they were deployed as containers, Docker containers. I will look into this Azure API administration, but I have used MuleSoft, and in MuleSoft, we can define these experience APIs, process APIs, system APIs. In fact, this design pattern, I think, came from MuleSoft. So
yeah, thank you. I think you answered the question, but we can't know any cloud specific tools, maybe only tools that we worked for. So another one question, thanks for the wonderful session. One question regarding securing the API calls. What measures should we take to secure these APIs?
This question is like a big question and not exactly in the presentation, but what the purpose of layers is that the layers tells us that, okay, we can have a separate security measures for the experience API layer and different security measures for the downstream domain APIs or system APIs or process APIs. Because when we used to classify the security requirements for the APIs, one question was that whether this API is an external API or an internal API. If an API is only consumed by other internal APIs, then obviously its vulnerability, its threat is less compared to the APIs which are directly consumed by the external clients or applications running in the external domain. So any APIs which is consumed only by the internal APIs, they can use like a we do in OAuth 2.0, that, okay, for example, I know that, okay, I have a system API which will be consumed by few domain APIs. So it can be configured that, okay, this system API can only be called by from these domain APIs, and no one from external can directly communicate with this system API. So this is configured, and we need some kind of SSO between these two APIs, but there is no end user involvement. Whereas the experience APIs, which are consumed directly by end user channels, they require user authentication. They might require JWT tokens and all those measures we take, like authentication, authorization. So, but the thing is that, okay, we need to classify that whether it's an internal API or an external API, and then define the security protocols according to that.
Thank you. Another one question regarding your previous slide, I think. What is the difference between experience service and XAPI in the picture? For my understanding, experience service also provides its own API and can be treated as XAPI.
Yeah, so I took the example of two separate designs, one from MuleSoft and one from eBay. So MuleSoft refers experience APIs, and they say that, okay, experience API is channel specific. So an experience API of mobile application cannot be consumed by a online application. And then I saw the design from eBay. In eBay, they use the term experience services, and they said that experience service is shared across channels. So you have some business logic which can be shared by all the channels, which is like, we can say that, okay, for example, customer details. Now, customer details are same whether in mobile application or online application, and maybe assume that the user UX of mobile application and the UX of online application, they display the same customer details in the same way. Everything is same. Then we can just build one experience service and let both channels consume this customer details experience service. So there, my motivation with this, using these two separate terms, is that experience API is channel specific, and experience services can be consumed by multiple channels.
Okay, thank you.
But an organization, anyone, they can use their own terms. These terms, I needed some way to, I use some name, right? So the names can differ, but this is what the difference is in this presentation.
Thank you. And last question for today: on which API layer SSO or any other identity management function should be implemented?
Yes. So when these internal APIs, which are communicating with each other, they need some kind of a SSO between them. So when one API calls another API, there is this call is between two systems, and so there will be no manual intervention to do authentication or input or login credentials. They has to be handled internally through some internal SSO mechanism. So like in one of the organization I worked, they had a separate SSO implementation for external and separate one for the internals. Separate external SSO was for end users, so they can switch between different applications, not APIs, different applications without doing login. Whereas internal SSO was for these internal servers or internal APIs or internal systems to communicate with each other without requiring an extra step of authentication. So when one API calls another APIs, there has to be some kind of a SSO, so that and this has to be done, and also depends like on the perimeter. On there can be example of open banking in which there is a different way SSO is implemented, and if it's all the APIs are internal APIs, there has to be some kind of SSO there, but it's slightly differently implemented.
Okay, so I don't see any other questions, and I think it's enough for today. So if you have some questions, you may still ask here. We may answer on them maybe later, or you may communicate with the speaker if you want. So thank you very much for a great presentation. It was cool.
Thank you.
I think it was enjoyable for everyone, and thanks for everybody who joined us. Just one favor, give us one favor, leave feedback about our meetup, and we would like to be better every time. Thank you, everyone, and have a good day. Bye.